Hello everyone, it's Akimbola Kende once again, and I'm making this video as a follow-up from where I stopped on week 3. So technically this is like the fourth week, and if you're stuck to a layman, that's like the fifth week. You usually count from zero as developers. So in the fourth week we did quite a couple of things. We went into smart contract proper, and I wrote my first ERC20 token, and I wrote it from scratch initially, and then also I made use of Open Zeppelin. It's a library where you can get a couple of reusable codes to like get the ERC20 token done. So, and also I wrote a multi-signature contract in such a way that before things can be done, an agreed number of admins must sign before that function can be called or before a decision can be made. And in the logic of this contract, I made it in such a way that before an admin is being added to be a part of the multi-sig contract, about 70% of the total number of admins must agree to have the person, and the same goes for deleting and then every other thing in the contract. I'll show you the contract in a little bit. And also from this multi-signature contract, I created a factory contract from it, such that I can create child contracts from this multi-signature contract, and anyone that interacts with my factory contract will be able to create something similar to a multi-signature contract without getting into the technicalities of it. And also we got into hardhat usage. I was able to deploy my first contract to testnet live network using testnet using Goerli. And I also verified the contract using hardhat. So yeah, I would show you my code base right now. So all right, so here is the first ERC token I wrote. I had to include a couple of comments to explain my code and stuff. So I have my state variables here. Basically, it's still following the same specification as Open Zeppelin, but then I wrote this from scratch. So yeah, and it has the transfer function. I made the old transfer logic internal, and then I called the transfer function over here. I made room for allowance, allow someone to spend your token within the contract. And I also included the approve function and then the maintain function, bond token. Here's the bond token transfer. This is just a logic that I called in here to bond token to the zero address, and this is one way. And I also imported from Open Zeppelin library to get my ERC20 token. All I had to do was just include the buy token function, and such that as you're buying the token, you're paying some amount of ether. So that's my first. These are my first two ERC20 token. One written from scratch, and the other imported from Zeppelin. So basically, I don't interact so much with this. So I'm just gonna, let's say the coin name is Kenny and the symbol is KEN. So if I transact this, so basically it has all, you can approve people to spend your token, you can bond token, mint token. Although this bond and the minting is limited to just the owner of the contract, that's the message sender that deployed the contract. You can allow someone to spend and check the balance token. So if I decide to mint to the contract address, let's say I want to mint about 50, say so this, and I check successful, I check the balance, it will be inside the contract. The balance will be inside the contract. So whoever is buying, once they want to buy, they pay some amount. Okay, this one does not give room for buying. It's the other one that gave room for buying. That was when I included this one. So basically this one I have to transfer to whoever wants to buy, and as I'm transferring, yeah. So here's the transfer, because I emitted it to the contract. So if I want to like transfer to people to other addresses, I can transfer using this function. So over here, if I deploy this one has um, the byte token function. So, okay. So yeah, I'm going to like impute just an address as the owner. So I'm going to transact. So yeah, you can buy token here. So all I have to do is just include the, if I'm buying, the way I did the logic, you buy one token for 1 ether. So if I'm paying 20 ethers, that means I'm getting like 20 tokens. But then yeah, so if I buy token successful, right, successful, and I check the balance, I should see 20 like 1,000 blah blah blah. Like it's 18 zeros. Oh, charges went off. So yeah, that's basically that. And I did my order, my factory contract, my multi-sig contract on my local machine. So there we go. This is my local machine. So I created a constructor that takes in an array of admins to set about 3 admins to begin with, and then I create several mappings to like check admin status and also check vote status. This vote count keep the number of votes because I created a function that keeps a voting pool. So as people are voting, this voting pool gathers all the votes and then checks whenever I need it. And if, for example, I want to like call admin function now, it first checks the total number of votes that has been gathered in this pool, checks it, calls it right here. So if the number of votes required is up to is more than the calculated the proposed amount of votes, then it is going to pass. But if the number of votes is less than 70%, then it is going to fail. So we can get addresses with this. This is an internal function that calculates the votes. This is the function that calculates 70% of the votes. And this function also deletes an admin. So, but basically, before you delete an admin, you also need 70% of the admins. So yeah, I create from this contract, from this multi-signature contract, I created a factory, a multi-sig factory, such that I can create new instances of that multi-sig contract as many times as needed. So anyone can come to the contract and then, create a multi-sig of their own. By implication, we can have child contract of the original contract. So yeah, and then one more thing I did. If you now imagine when I create a new child contract from this function, how will I interact with it? All I need is once it is deployed, it will return the contract address of that child contract. Then I make use of an interface to interact with this child contract. So while testing my code, I wrote a script using TypeScript to interact with my contract. So I created an array and I out of addresses. These are live accounts. These are real accounts because I deployed it to a testnet, Goerli testnet. So and then I included these addresses, the private key. I kept them in this .env. I'm not going to open it because it has my private keys. And then I included this .env inside my git ignore such that when I'm pushing this to my GitHub repository, it will not read my .env file. So yeah, and yeah, okay. So this line of code right here is storing the addresses over here. Because technically in this owner and owner 2, owner 3, it has both the address and then the private key in it. So I have to like target which of them I'm looking for, which of them I want to use in this array, which is the address. And this get contract factory, this is the name of my contract over here, and I deployed it. I saved it in here and I deployed it over here. So I have to like wait for it to be deployed because the way Ethereum blockchain, the way the blockchain works, it's kind of slow. So I have to like wait for it to deploy before I console.log this deployment successful your multi-signature addresses. Yeah, so in here I will get my contract address of the multi-signature address once it is deployed. So now if I want to now create, if I want to like interact with the function, one of the functions inside my, yeah, this is the function here, the deploy contract function. So all I have to do is come to my TypeScript and then evaluate, and then multi-sig, this multi-sig factory over here, that's like the contract address that we got here, and then to interact with it, so I have to like call the function, and then because originally the multi-sig factory takes in an array of admins, so which I passed in here. This is the array of admins over here, and I passed it in here, and then I have to like wait for it to like create, and then in this wait function that I called over here is going to like return quite a number of information to me, within which I'm going to get my contract address. And then initially I created an event. To like return the contract address of the child contract, which I found inside my events.args over here. Event at position 0 and then args at position 0. Then it's going to return my child contract. Although I had coded it here because I was trying to like interact with my child contract over here. So technically I'm meant to like passing this contract address over here. I didn't have not gotten a child contract address initially. So I included it here so that I would be able to like interact with the child contract. So I was able to deploy it. I got my child contract, I think, over here. If I got quite a couple of errors while trying to like get this done. So initially, this was where I got my child contract. Initially, it didn't go through because of the blockchain was quite congested. So I had to like block out. I had to like comment out some part of the code so that I would like interact with the code that was not initially implemented. So this was just me trying to interact with my child contract, and these are owners that have to like sign. I didn't specify which of the admins that will be signing. Hardhat will automatically pick the first one inside my .env file, which is not what I want exactly. So after I specify, okay, for me to like have 70% of the vote, I have to like implement. I have to like include each of those admins for them to like vote. And over here, I picked up an address and I added it as an admin, which actually worked. And initially, when you take a look at this code down here, when I console log this get address, it return this, and then when I run this votes code, and I ran and he added admin, called this admin function, then it's added successfully, and then that was why the number of admins turned to 4 addresses. So we're going to take a look at this contract address on Open Zeppelin. So let me first copy the multi-sig address at first when it was deployed. Where is it? It should be right up here. All right, this is it. So I have to go to Goerli testnet. Scan to check the details of the contract address. So this is the multi-sig contract address. If we search for this, see it is deployed live. This is when I called the deploy contract address over here, and then I verified it using hardhat. So you can see my code, my line of code in here, and then the creation code, bytecode, and stuff over here. So if I search for the child contract as well, which on Etherscan, so if I paste this, click one more, just paste it in. Okay, paste this in here, the child contract. So the child contract is also verified. Yeah, this shouldn't be what I'm looking for. Let's copy this again. All right, yeah, there it is. So yeah, these are the. If you take a look at my code here, when I was trying to interact, you see vote contract, vote function, vote. So it called all the votes function, and then they called the admin function. So it is reflecting as I'm interacting with my child contract from my script. It is reflecting over here. So if you check the see success, so technically that's that. And the verification, this verification was done using hardhat. And this is a line of code that I used. Should we write about the, yeah, this line of code over here, this is like a deploy contract with constructors. And then if it has no constructor, all I need to just to do like npx that's verified and the contract address. So if there are any other argument, maybe just a less complex constructor, maybe just one of the argument, then you can pass it just at the back over here, and then you dash network Goerli. So that's that for the just concluded week, and I have a task to finish up. I have a task to create a token voting platform where you vote with tokens, and it has to like take the has to take the shape of a an ERC20 token and a voting logic stuff. So when I'm done with it, I will come back next week to tell you all about it. So yeah. All right, that's that. Thank you for sticking around to take a look at my code base. It's not the best, but at least we are still growing. And then in the coming weeks, I look forward to learning more things. And when I learn them, I'll come back next week to tell you all about it. Thanks for sticking around. See you next week. Bye.